Okay, everyone, dotnet Conf continues with more awesome sessions. Now, next up, we have optimistic updates with Blazor and Entity Framework Core. Our next speaker is ready. Let me introduce you, Emmanuel. Hello, welcome, Emmanuel.
Hi. Welcome to the others, not to you. We are just yeah.
Awesome.
Yeah, I mean, it's not easy to deliver a session after the latest two sessions because they are very interesting, but let's see. I will try to do my best.
Yeah, so we're so excited to hear more about optimistic updates with Blazor and EF Core. So over to you.
Yeah, thanks. So, yeah, thank you for sharing my screen. So first of all, as a developer, we are, let's say, pessimistic people. I mean, because every time we think about the most pessimistic scenario that we can have when we click on a button or stuff like that. So, this is why the other framework like React or Angular or stuff like that, they implement almost by default optimistic update. But say, what is an optimistic update? Optimistic update is an improving user experience to updating, say, the UI before have the confirmation from the server that something changes, like saving a record on a database or I don't know, calling an API. Okay, so you update to the UI before the final confirmation from the server. Okay, but let's say you see these updates, optimistic updates, every day. I mean, more or less, everyone use Facebook more or less, and when you add a comment and you click on the button add comment or stuff like that, you see the comment just below the previous comment or the post. Okay, but of course, in that case, it's not saved very quickly, but they update just the UI. Or you can have also another experience with optimistic updates on e-commerce website when you add something on the basket or stuff like that. You see your basket updated with an animation or stuff like that, but maybe the record is not there. Okay, or other example is like online games do the same. Twitter, when you send a tweet, you see the tweet just below your text box, but it's not saved on a database. Okay, so we use optimistic update every day in our application, in their application, but not in our application like Blazor, for instance. So this is why I try to implement the same approach to a Blazor application with some, let's say, easy tricks. First of all, you need to share the data context, of course. You need, say, as we know, the data context, the DB context with entity framework across the component and across all the application, like dependency injection is fine for this case. But first of all, I want to mention a thing. We don't have to change the entire application to implement optimistic updates, but just some tips and tricks around the application. The second one, you can implement the change tracking for, let's say, when you change a value on a component, maybe you want to update another component. And then in this case, you can use a state management system, but it's not mandatory. It's just up to you. For instance, in many of my applications, I don't use a state management system because I don't need it at all. And of course, for instance, what you can have here, because you can receive a lot of requests on the database at the same time, because you update the UI and you send the message to the server to an API or wherever you use, or just a service behind. So this is why you need to implement a strategy for resolving conflicts very often. I mean, if you have a lot of users on your application, web application, maybe it should be a good idea. In general, even without optimistic update, but with optimistic update, it's more usual to have conflicts or stuff like that. And then, of course, you have to update the user interface if you receive an error. But keep in mind that most probably the 99% of the time in a normal application, you don't have errors, okay? So why I have to implement all the loading or fake animation for saving records when the 99% of the time it works. So this is why optimistic update is a good idea to implement. So, but say we are developers and we love the code, so I will show you how it works. In this case, I created an easy application, easy and simple application, where you can upvote or downvote a record. Okay, I will show you before the application when runs. Okay, so this is a normal application, nothing special. I mean, I just created the application with the template, and then I add these records. I will show you the code later, when you can upvote or downvote something. As you can see, when you press the button, you need to wait the answer say from the server about, hey, I updated the value, and you update the value as well, right? Okay, this is more or less how it works, more or less every day, every single application that we develop. Okay, but let's see. Let's take a look to the code. What I've done here. First of all, I created a DB context, and I use any memory database just for the demo, but it doesn't change if you use a real database. And I created some fake data, okay, just to be more quick during the demo. And then I have only, in this case, only these models called what item. And in this model, I have these fields like the ID, the description, the count, and the last update. This is more important. It's very important for what I will show you later during the session. Okay, and then I have a service, an interface, first of all, where I can receive all the, let me zoom a little bit, okay, where I have, let's say, my retrieving function for retrieving all the records from the database, upvote and downvote a single item. And then I implemented my repository, let's say my service to work with the interface in a real implementation. As you can see, I have the function for retrieving all the records. Of course, for the demo, I put here a kind of delay to emulate a slow answer from the server. So this is why you see the disable button for a while, because I implemented this delay. But of course, it should be almost real when you call an API or stuff like that. Okay, and then easily I update my item, and as you can see here, update also the last update, and then I save update the item, and I save everything on the database. It's more or less what we do every day. Of course, this is an easy architecture for the demo, but it should work. And then from the UI perspective, what I've created in my home, I have my uninitialized async. When I retrieve all the records from the service directly, and then I show the component say directly on the UI. As you can see, I created this component for voting, and as you can see, I have two buttons: voting, upvote and downvote button. And when I click on the upvote button, I call my service to upvote an item. Okay, very easy. And then, as you can see, I implemented in the UI a logic to disable or enable the button when I'm done. So this is, again, more or less what we do and what I do every day, because honestly, I use the same approach very often, because we don't have to implement optimistic updates, let's say, always, but I will talk about it, let's say, later. Okay, and then it's very easy, but now I want to start to implement the new logic for implement optimistic update in an application. So what I do here, I created another services for demo, of course, because I remove a lot of things from here. As you can see, when I create the upvote, in the upvote function, I have always the delay to manage the slow answer from the server. I implement everything again, like last update or stuff like that. But with the entity framework, I can say, hey, if you have an error about the concurrency, okay, like in this case, I can check why I received this. I have to manage this concurrency. In this case, I use the last update field, but you can implement your logic. And then when you implement your logic, you need to know what you send, say to the user. I mean, you can reload the last value, you can update manually the value. In this case, I reload all the entry for the database. Okay, and then for the downvote, I do more or less the same. Okay, this function, of course, this method should be, of course, let's say a common method, say with parameters, but just because of the demo, I will show you later why I created, say, 2 of these. Okay, so in this case, we implemented this the concurrency exception very easily, and then you can have this code more or less in your whole application. And in my component, I changed a little bit my component, as I can show you here. I have the same button as before. As you can see, my disable button here, upvote button and downvote button are the same, but in the code, I changed a little bit the code below. First of all, I added a paragraph with the error message, okay, where I have to show the message if I receive an error. Because again, if you come back to the example that I mentioned at the beginning, when you go to Facebook or Twitter and you add a comment, maybe you don't have the connection, maybe you have other issues. Sometimes you receive a message from the server like, hey, this comment is not added or updated or stuff like that. Because in this case, with optimistic update, you need to pay more attention in details like this to update the UI, managing the errors from the server. Okay, it's a little bit more tricky as before, because maybe before you can just have a message like, hey, there is an error, or an alert, a pop-up, or stuff like that. But in this case, you can, say, like on Facebook, you can still continue to navigate to the application because you push the button maybe more than once in a grid or stuff like that, and then you have to manage all the single item. And this is why I created a component, a single component for a single item, because of course I can also implement everything here, but is more let's say difficult to implement the answer from the server. Okay, this is why it's important also to create small components for managing optimistic update in your application. Okay, and then here I created this error message label, let's say, and then more or less I use the same parameter as before, but as you can see here, I can remove also this Boolean value because we don't need it anymore. And then I update the value directly in the UI, okay? But first of all, as you can see here at the line, say 28, I update the value directly, say on the UI. But first of all, I need to save my original values, because if I have an error on the server, I have to restore the previous version of the value, because as you can imagine in this example, as upvote and downvote, if I update the UI and I add a number, say I add say +1 to the upvote or downvote in this case, of course the UI is not reflecting what's happened on the server, of course. So this is why I need to save the original value, and if I have an error, I have to restore. And another example, you have the same behavior when you post, again, a comment on Facebook and you have an error. They get your comment, your original comment, and they bring it back to the text box, because you don't have to rewrite everything. And in this case, so you can do the same. Of course, in this example is more easier because you have only just, let's say, an upvote with the value, but the logic is the same. And then I add a little bit logic for try to update the value on the services. So the code is the same, but just surrounded by a try-catch in this case. So when you click upvote, we update in the logic, say the vote. But if you receive an error, okay, we can add the error message directly to the label. Okay, so this is why when I call the method at the beginning, I reset the error message. Okay, because in this case, if I have an error, I can try again, and then I clean everything because I try to upvote again or downvote again, and then this is why I reset the label. Okay, and then if you have an error, as I mentioned before, you need to restore the original values. Okay, this is why I put this original value, say both item dot count equal original value. So you need to restore everything. And then this is important. This state has changed is important in this case because, of course, this operation is not, let's say, in real time, but you have to wait a little bit because the server answers after 3 seconds in this case, and you need to refresh the UI. Okay, so now I try to change my application. Let's say we use the new component here, and also in the program JS, in program JS CS, I have to update the UI, let's say the service. Okay, I didn't mention before, but as you can see, I use let's say the most easiest version of the dependency injection. So I add the DB context to the services and the scoped services for our iBot service interface. Okay, and in this case, if I launch the application again, let's see. I think I remove all the things of the previous version, but let's see. Then he load, and then as you can see here, I don't have any, let's say, waiting time anymore because I just send all the things directly to the server, ignoring the answer, okay, and update everything, and say in real time. And as you can see, if you don't trust myself, and I don't trust myself as well, if I come back, I restore, I recall the service to say load again the value, and as you can see, the value are changed and saved on the database. So as you can see, it's very easy to implement this optimistic update, but it's not easy to try the error say on the server side, because of course in this case I just want to be sure that I don't have any concurrency issue. And what I did here in a very easy way, in the downvote version, I just throw an exception to see what's happened in the UI. Okay, because it's not easy to implement a logic to test this part. And another things that I want to mention is very easily also to test the component with the test libraries for the UI, also like Playwright or just component testing inside Visual Studio, because you can implement your logic to test the components very easily, because the component in this case it's a very small piece of code, and you can implement also say this service with an interface with fake data and mock data, and this is why I also use very often the in-memory database instead of a real database. Okay, and then in this case, when I try to download something, in this case I just put an exception say manually here, and as you can see, when I try to upload, it works. When I try to download, I refresh the value directly, and then the exception, as you can see, it waited. I mean, the number is updated, let's say live. Okay, it's 46, right? And then I launch an exception, and let's see what's happened. Okay, issue my message, hey, you have an error, and the vote, as you can see, is restored with the previous value of my upvote. Okay, and then I can try again if it works or not. as you can see, I refresh everything, I remove everything, and then as you can see, it works again because it downvote again. Okay, if I try to remove this breakpoint here, is more clear again. I change the page, upvote and upload is two similar words. It's not easy to pronounce correctly. And then if I press downvote here, as you can see, after a while, I receive the error message and the vote is again was before. So this is more or less how it works, this approach. Of course, you can implement a lot of, let's say, most complicated logic, but to understand how it works is very easily. And as I show you, I didn't change my application too much to implement this approach, because optimistic update is just an approach to manage the UI and maybe something on the service behind. But as you can see, I just removed something. In this case, the UI is also sometimes more easily and less complicated, because in this case, I remove all the logic to add some loading stuff, disable buttons, stuff like that, because it's easier to update the UI in this case. Even in more complicated scenarios with more complicated, let's say, scenarios and business logic, let's say. And when we need to use optimistic update, of course, we don't have to use optimistic updates always and in every project, because maybe you don't need it. I mean, if you have, for instance, an application with a lot of forms, with a crowd application, with a crowd operation, maybe is not the right place to implement optimistic updates, because in that case, it's hardest to update all the UI with all the values in the forms and stuff like that. Maybe in that case, you can implement optimistic update in the entire application, except for this particular, for let's say that particular forms. Okay, and of course, it's very important to implement robust error handling. As I showed you before, this is not, say, my example, really robust, but it's just a starting point, because you need to implement a robust error handling, but first of all, also a rollback mechanism to restore the UI data in the right place. Okay, this is maybe the most important thing, and maybe the most complicated thing to implement in this case. Of course, you don't have to implement. You can implement, but it's better if you don't implement optimistic update where you need to use, say, sensitive data like payments, password, or personal information, because you need to update the UI, and maybe you don't know if the payment is done or not. So maybe in that case, it's better a redirect or say something, let's say, normal, let's say. Okay. And then also it's very important also to manage and test your code in the different scenarios, like slow connection, no connection as well, error on the database, stuff like that, to be sure that you manage the most important errors in your application, and the most most important error. Then I give you some resource. Of course, I use dotnet 8, but in this case, is not super mandatory. We share some link here about also entity framework core, about the concurrency part, and you can find after the session all the let's say a blog post on my blog, because I create a kind of summary of the session in the written version, so you can easily have a kind of recap of the session directly on my blog post. So thank you very much. And I don't know if we have questions. I hope not.
Thank you. Emmanuel, we just have a couple. I think we have time. I can ask you. So we have one question. Why do you need state has changed? I thought this happened automatically.
Yeah, state exchange is a kind of religion. Sometimes you have to add without any reason, let's say. And in this case, because you wait too much and you have a sync operation behind, you need to add the state exchange in this case. So this is why I added the state exchange. Say to refresh the UI with the new values like error or stuff like that.
Okay. And we have one last, I guess, question. Is async void a good practice in the Blazor component for async logic?
Is a sync? Oh, wait. Sync void is a good practice. No, I mean this is of course just demo sample. So I don't put, let's say, too much attention, let's say, on these details about async. I mean, I put attention, but at the same time, it's not let's say a session about the component. But of course, very often I use the async practice also in components, of course. Yes.
Okay, awesome. I guess that's what we have so far. Thank you so much for joining.
Thank
and
you.
Awesome presentation, by the way. Thanks for being a part of .NET Conf, and hopefully, maybe we will see you next year as well.
Yeah, I hope as well. Thank you very much.
Thank you.
See you.